Hi, my name is Sarnija and you're watching Bring Security. We are solving the advent of cyber by TryHackMe and today is day 13 and topic is YARA rules, YARA mean 1. Let's get started with the story. When McSkidy went missing, there was chaos and uncertainty at the TBFC company. However, even in her disappearance, McSkidy was trying to help the TBFC blue team. Taking a page out of the crisis communication process, McSkidy sent what looks like a bunch of images to the blue team from an anonymous location. These images looked like they were related to Easter preparations, but they contained a message sent by McSkidy. The blue team has to create a YARA rule that runs on the directory containing the images. The YARA rule must trigger on a keyword followed by a code word. After extracting all the code words in ascending order, the blue team will be able to decode the message. Learning objectives: understand the basic concept of YARA, learn when and why we need to use YARA rules, explore different types of YARA rules, learn how to write YARA rules, practically detect malicious indicators using YARA. So let's get started. At this stage, McSkidy, the lead defender, has entrusted you with a mission involving the use of YARA rules. Before jumping into action, let's take a closer look at what YARA is, how it works, and how it's such a valuable tool in TBFC's fight to protect SOCMIS. YARA is a tool built to identify and classify malware by searching for unique patterns, digital fingerprints left behind by attackers. Imagine it as a detective notebook for cyber defenders. Instead of dusting for prints, Yara scans code files memory for subtle traces that reveal a threat's identity. Now, what is Yara? It is malware classification and detection tool. It is used to identify patterns, unique patterns that a malware can follow. It does not simply tell you that okay, this malware is present on the list that you specified, so I will put the red flag on it. No, it actually identifies how a particular code would run, how a particular file would act, and it would gauge patterns, it would gauge behavior, and then it will flag it as malicious. So that is how it is more refined and more advanced way of malware classification. Now in Yara, you write rules, that is basically strings that would tell the tool that you have to detect this kind of particular malware. We will do that exercise further. We have to do that image thing that we saw in the introduction part. Now, in what situations might defenders rely on this tool? Post-incident analysis to check if there are traces of malware, to check if malware found on one compromised host still exists elsewhere in the environment. Threat hunting, searching through systems and endpoints for signs of known or related malware families. Intelligence based scans, applying shared YARA rules from other defenders or kingdoms to detect new indicators of compromise. An employee from company A can write down rules that they found useful to detect malicious code, and company B employees can use that as well. Then we have memory analysis, examining active processes in a memory dump for malicious code. The examples above show common uses of YARA, but defenders often find even more creative ways to apply it during investigation and hunts. Now, YARA values: constant battle to protect SOCMIS, time and precision matter the most. That is where this tool shows its true value. It gives defenders clarity in chaos. With YARA, you're not waiting for an antivirus update or third party alert. You're not using a dedicated software. It is just it can just be used by your own terminal. You have the power to create your own rules. You don't have to wait for third party. Detect new variants and act before threat spreads. Like if you found an alert to be of prime importance, you can just modify the rules and quickly prevent more damage in your system. For TBF's defenders, Yara brings several key advantages. It is speed, flexibility, control, shareability, and visibility. Helps connect scattered clues into a clear picture of the attack. This tool empowers defenders to move from passive monitoring to active hunting. You don't sit on your monitor screen waiting that things will get sorted, you will get alerts, and then you will act. You can actively look for things using this tool. turning intelligence into action before the attackers strike again. Then we have the rules. Rule is built from several key elements. It is metadata, strings, and conditions. In basic, in most basic words, we can say metadata is data about data. So information about the rule itself, who created it, when, and for what purposes. We saw earlier that somebody from company A can share those rules with company B. So the person who wrote it here, they write their information, why they wrote it, and what is the reason behind it, and what the rule does. That is metadata about the particular rule. Strings, the clues this tool searches for text, byte sequences, or regular expression that mark suspicious content. Now, in strings, there are three types. You can either just write plain text, you can write byte sequences, or you can use regular expressions. We can ask echo for simplest meaning of a regular expression. Sequences of characters that form a search pattern. Regular expressions in itself is a long topic. Then we have conditions, the logic that decides when the rule triggers, combining multiple strings of parameters into a single decision. Metadata is data about strings, like why would you write it and what is the reason and who wrote it. Strings is the underlying rules that are to be executed, and the condition is the logic that executes this rule, that determines in which scenarios these strings will be used. Here's how it looks in practice. We have rule TBFC King Malheur trace. Meta, author is defender of Sockmas. Description detects traces of King Malheur's malware. Date is this. String 1 is this file. Full word ASCII. S2 this file .dll. Full word wide. URL 1. Now this is a regular expression. It says that I'm not very good at reading a regular expression, but I can gauge from here that anything before and after malware, and it's HTTP. Any URL that has malware somewhere in the middle with anything in front and anything in back or nothing, you have to detect it. Condition, any of them, any of this should be there. No case. That means anything should be detected. In this example, you can see that meta section contains fields like author, description, and date. Fields are not required, but they are highly recommended. Just like when you write code, documentation is not required for production, but it is highly recommended so that we understand things, right? Because when you see this thing after 10 days, you would not remember why you wrote it. Or if you want to tell somebody else, how would they know? They help you and other defenders understand what the rule is about, who created it, and when was it written. When your collection of YARA rules grows, having clear metadata will save your time. We have strings, we have text strings like this that simply just say the name, the letters, the words, simple. And then we have case insensitive. That means no case. When we add no case, it means that adding the no case modifier makes the match ignore letter casing. So Christmas and Christmas or Christmas will all trigger the same result. Then we have wide character string, wide ASCII. Many Windows executables use 2-byte Unicode characters. Adding Y tells YARA to also look for this format. When ASCII enforces a single byte search, you can use both of them together. Then we have XOR strings. Malware's agent often XOR encode text to hide it from scanners. Using the XOR modifier, YARA automatically checks all possible single byte XOR variations of a string, revealing what attackers tried to conceal. Next is base64 strings. Some malware encodes payloads or commands in base64. With these modifiers, YARA encodes the content and searches for the original pattern, even when it's hidden in a encoded form. So these three are some common methodologies in which text is stored. First, it is wide character string. Over here, what computers does when storing a single letter in ASCII, it stores 1 byte per letter. That is why it says single byte search. And when we talk about Windows executable, they store 2 bytes per letter. That is why it is said over here wide ASCII. Then we have XOR encoding. XOR encoding means this particular text is XORed so that you cannot directly read it. Then we have base 64 encoding. When you write strings like this, they can be encoded like this using base 64. Then we have hexadecimal strings. Sometimes the malware's code doesn't leave readable words behind. Instead, it hides raw bytes deep inside executable memory. That's when hexadecimal strings come to rescue. Then you have regular expression, same thing. Nobody is going to write the entire code or the entire file name like this. They are going to find a workaround. So we also have to try all possible ways to detect such things. Then we have CMD and URL. Reject strings are powerful but should be used carefully. They can match a wide range of data and may slow down scans if written too broadly. Now, if you're scanning each and every input that comes, then your system becomes so slow that it would affect you inversely. Then we come to conditions. Now the defenders of TBFC know how to describe what to look for using strings. It's time to learn when that should apply. That logic lives inside the condition section, the heart of every rule. The condition tells YARA when the rule should trigger based on the results of all string checks. Think of it as final decision point. And let us start to read the next part. Match a single string condition if this particular string is found. For example, we wrote here Xmas. If only this string is found, then generate an alert. Then any of them, any of the strings that we have specified earlier, we wrote about URL and CMD as well. So any of that is encountered, throw an alert. Then we have all of them meaning all of them must be there. Any one would not be enough. Then combine logic using and, or, and not. Boolean logics. Then use comparisons, any of them, and file size is lesser than 700 KB. Entry point or hash. Study cases. First we have metadata, TBFC SOCL2. Description is this, ICE ID rule. Date, confidence low. Okay. Strings are, this is hexadecimal. Okay, so here first it says MZ header, meaning this is some hexadecimal representation, and MZ header means every Windows exe file starts with this, and this string stands for that particular thing. I think PE stands for program executable. Does it? Yes. Object DLLs, file formats for executables. Format is a data structure and encapsulates the information necessary for Windows OS to manage the wrapped executable code. Then we have a hexadecimal, some representation, malicious binary fragment, meaning there is some malicious code inside, which is of this pattern. Starting and ending is something like this, and in the middle it can be anything. Then we have normal string. This is AoC, indicator of compromise. Conditions, all of them, and file size is lesser than 10 MB. See how helpful comments are. We can use man YARA command to find out what flags could be useful in our scenario, and we find the following. R allows the tool to scan directories recursively to follow symlinks. S prints the string found within the files that match the rule. Putting everything together, YARA command recursively scans C drive using the istate rule file and can optionally display the matching strings when using -s. Okay, this is the command that I used. Okay. Next is an interesting task to create our own YARA rule. It's time to complete the practice. The blue team has to search for keyword this, followed by an ASCII alphanumeric keyword across the directory to extract the message sent by McSkidy. Can you help decode the message sent by McSkidy? That is first. We have to go to downloads and Easter. So our machine loaded. Now we are first going to go to this directory using the terminal. I'll also have a look through the GUI. What do they want us to do? Downloads, Easter. Yes, normal Easter images, but they have something hidden in them. So many images. There are 60 images. Alright, go to the directory first, /home/. There are just images in this particular directory. Now the first question is to find how many images contain the string TBFC. First, let us keep this sample rule towards the left. Let us take an even simpler case that was given in the beginning. Let us try to write something like this using the nano editor. We will say nano rule name, we will say find underscore TBFC, and we will write rule find underscore TBFC. What does this mean? That we want to find a string called TBFC, and we will do Control O, enter, Control X. Done, our file is written. Now we will run the command that was present here. We will save. Why did we use a dot here? We want to say that run this command in the current directory. Let us see. Wrong number of arguments. There is something undesirable that we did. We did not use space. We made a silly mistake. We just created the file name as find underscore TBFC, and over here we have to write .yar. So we will use mv command to rename the file from find TBFC to find TBFC underscore, sorry, full dot yar. Done. Now let us run that previous command. Should work. We have 1, 2, 3, 4, 5. 5 images. What regular expression would you use to match a string that begins with TBFC followed by 1 or more alphanumeric ASCII characters? Now I don't know how to convert into regular regular expression and alphanumeric characters. Let us see the hint. Have a look at example. I did. I think we have to go for this. Capture everything after TBFC. Because over here it says match a string that begins with TBFC followed by 1 or more alphanumeric ASCII characters. There we go. Nano find TBFC. Where's S2? Here is a regular expression, not a text. Won't be using this. We can erase the S1 rule as we are just going to use the S2 string over here. Over here they had forward and backslash. I think that is what we missed out on here. We cannot work with unreferenced rules. I made another mistake here. In the regular expression, it said that we are scanning for text files, so we cannot use the $sign because it is when the expression has to end with a word, I guess. That is why it didn't work. Let us try it now. Yes, now it worked. TBFC Hopsec find island me in. Find me in Hopsec Island. Okay, you're asking for the rejects only, and we kind of chat GPT that. Okay, I don't know about how to create regular expression, not good at it. Just going to copy this from here. Next, what is the message sent by McSkidy? find me in Hopsec Island. And we're done. Finally. That is it for today. See you in the next challenge.